everybody, welcome back boys and girls. It's your main math man, Mr. Shank, coming to you live from Summit Academy. In this video, where we're still working on that unit 4, lesson 14 now, solving those systems of linear equations, and we're going to be able to graph them out using Desmos. So in the first part, to solve these without having to write anything down, what I want you to do, real simple, notice how they are put together. So it's saying, these two pairs of equations or this pair of equation goes together. So this is being graphed on one line. So what I'm going to do is I'm going to graph each of these one pair at a time. So let's pull up Desmos. Again, make sure you can have it set up for yourself like so. And so what I'm going to do is I'm going to type in exactly what I see. So I have x equals 5, going to be a vertical line up and down, and then I have the linear function y equals x minus 5. What I'm looking for is a solution point. So I'm looking for where those two lines intersect. And real simple, again, notice how the two lines are colored differently, so that way they're easier to see. But we're saying, the solution point is going to be that point, it should be 5 and x minus 7. There we go. So that means that the point that we have is going to be 5, negative 2. So for this one, we're going to say the solution point, pull it up, we're going to say the solution point for this one, again, make sure you're saying solution point is the same as the point of intersection, which means you're looking for an x value and a y value. So it should always look like this, where you're writing, an ordered pair. So an ordered pair. So we're going to say for this first one, let's say, 5, negative 2, because that's where those two graphs meet, or where those two functions meet. Let's do the next one. Next one is going to be like this. Get rid of these. Now I can say I have y equals 4. That's going to be a horizontal line because it's y equals a number. And my other function is going to be y equals x plus 3. So find where those two lines intersect. I can say, hey, right there is where they intersect. So it's going to be at the point 1, 4. So let's pull this up so we can write it. So we're going to say this one, the solution point is going to be 1, 4. Then it makes sense too, because if I look at these equations, when I plug in 1 into this equation, 1 plus 3 equals 4, and regardless of whatever my x value is, my y value will always be 4 for this equation. And for the last one, let's graph it out. So this one should be super simple too, because it tells you what the two values are, but I can graph it out to prove it. So I'm going to say I have x equals 8, and then I have y equals negative 11. So I need to find where those are equal. You can move your graph around so you can see it, but notice how I have a vertical line for the x equals number and a horizontal line for y equals a number, but that is a direct point. We're going to say it's 8, negative 11. We could have predicted that from the start, but we're going to write it in here like this. We're going to say, okay, for this one, it's going to be the point where those two lines are equal. It's 8, negative 11. So again, wherever you have a solution point is where they have a point of intersection. All right, same idea for this section now too. It says here are a lot of systems of equations. Again, a system of equations is just, it's at least 2 equations on the same coordinate plane. That just means on the same graph. And coordinate plane is graph. Okay, so it gives you some options. What I want you to do is pick choose 4 to solve. And what I want you to do is graph them on Desmos. So at this time, I want you to pause the video and choose 4 different systems and then find their solution points. And what I mean by that, make sure you're thinking of, you're going to say an x value and a y value. So let's say, for example, if I picked that point, or if I picked the system D, I would say, I have an x value and I have a y value as a solution point. So pause the video, pick 4 of those, be sure to check and make sure you can check with me. All right. So pause the video, find the solution point on 4 of those systems. All right, so now that you finished that last part, for the next part, it says Tyler was looking at the system of equations. So it has x plus y equals 5 and x plus y equals 7. So he said, just looking at the system, I can see it has no solution if you add 2 numbers that the sum can't be equal to 2 different numbers. Do you agree with Tyler? So we could say, let's say this, we could say yes. We could say when you graph the equations, the lines are parallel. This means there are no solutions. So anytime you have those parallel lines, that means they have no solutions. And then I can prove that by showing you what the graph would look like. So let me clear this out real quick and enable it. All right, so we're looking at the system x plus y. Let me hit that little home button. There we go. X plus y equals 5 and x plus y equals 7. So exactly like he's talking about 2 numbers, the same x and y, that add together to be equal to 2 different numbers. So notice how that works. So we're saying, compare those 2 lines, they're parallel. That means they have the same slope, but a different y-intercept. So that means that they have no solution for this system because there's no points of intersection. All right. Next part on the back, I want you to be able to solve these 2 equations. So write your solution point. So pause and graph in Desmos. So this video is super simple because a lot of it is just being able to solve by graphing. Make sure you write the solution point. Again, solution point is an x value and a y value. So make sure you can pause the video to get those 2 solution points. All right, for number 3, it says which equation together with y equals negative 1.5 x plus 3 makes a system with 1 solution. So let's try graphing out. So what I'm going to do is this. Let's enable our picture. So we're talking about the equation. It's saying given the equation y equals negative 1.5 x plus 3, it's saying, okay, what is going to be a solution for, or what makes a system with 1 solution? So if I look at the next one, I would say y equals negative 1.5x plus 6. Notice how those are parallel lines, so that's going to be no solutions. If I look at the next one, I would say y equals negative 1.5x. Same idea, parallel lines, that means no solution again. Let's go to the next one for that choice C. It has 2y equals negative 3x plus 6, or sorry, negative 3x plus 6. Find where that's at. That's actually the same exact line because, again, if you lose it, you can always, highlight it again. Notice how it's the same exact line over top of each other. So that's not one solution. That's going to be infinite solutions. So let me try the next one. It's 2y plus 3x equals 6. Same thing. This is also going to be infinite solutions. Notice how the lines overlap each other. And then the last one is going to be y equals negative 2x plus 3. So these two lines, let me actually change the color. There we go. So we have two lines that are intersecting at one point. That point is 2, 0. So let's write some of these notes down. So we're going to say for A, it doesn't match up because this is no solutions, because it's parallel lines. Same idea for the next one. We're going to say no solutions for parallel lines. For that choice C, this is infinite solutions because it has the same line, or you can say overlapping lines. So I'll say that for this one as well, infinite solutions because it's overlapping lines. So if it's the same line, it's going to be infinite solutions. Again, be careful when you're looking at the picture, that way you can change it. But for that last choice, that's the one we're looking for. And we're saying one solution because they intersect at one point, and that point was 2, 0. Let me double check one more time on the picture. Yeah, 2, 0. So 2, 0. So you're gonna make sure you're using that wonderful graphing calculator to the best of your benefit. All right, moving to number 4, it says the system x minus 6y equals 4 and 3x minus 18y equals 4 has no solution. So it says to change one constant or coefficient to make a new system with one solution. So what I'm going to do is let's look at what that picture looks like. So I'm going to clear these out. And so it was talking about, it says x minus 6y equals 4. There's one graph. Then we have 3x minus 18 equals, 18y equals 4. So notice how they have parallel lines. We have two different equations here, two different lines. They are parallel. That means they have no solutions. Let's also talk about this. So let me actually talk about what these mean. Again, when you see the word constant, when you see that word constant, it's talking about a numerical value, so just a number. When you're talking about a coefficient, however, so let's say a coefficient, make sure you see the difference between these two. So this is going to be a number attached to a variable. And when I say attached, I'm talking about, it's being multiplied or divided. It's being multiplied times the number. So for example, some examples of a constant, I would say a constant in these systems would be 4 and 4, where a coefficient, you could say, well, this has 1, this is going to be -6, this is 3, -18. So notice the differences between, they're both going to be numbers, but one is all by itself, where the coefficient has itself attached to a variable. All right, so what are we going to do? Well, let's change something about this. So I'm going to change one coefficient to make a new solution, because since they have the same slope, that means they're parallel. So if I change a slope for these equations, then I should be good. So I'm going to change first equation. Yeah, let's change first equation to be, let's say, instead of just 1x, let's say 2x minus 6y equals 4. Let's see what this looks like on our graph. So all I'm going to do, notice I already have it typed in, and notice how it's essentially like I have a 1 right. Oh geez. It's essentially like I have a 1 right here. Notice how it doesn't change. But as soon as I change it to a 2, notice how it changes my slope. So I'm going to change this to a 2. Notice how it gives me a point of intersection. So I have one solution point. All right. For the next part, it says to change one coefficient. Oh, let's kind of do undo. Let's try moving this. There we go. It says we'll change one constant or coefficient to make a new system with infinite solutions. So what can I change to make them the same line? And so let's say this. I'm going to say change, let's do purple. Let's say change second equation to be, let's say 3x minus 18y, so that part stays the same, but let's actually change the constant in this equation. So we're going to change it to be 12. And so let's try this out. If I notice and I look at these two equations, it's almost like the first equation is being multiplied by 3. So if I change this constant, so let's try this out. Watch as I increase these numbers. So instead of 4, I have 5. Instead of 5, I have 6. Notice how it's getting closer to that line. As soon as I get to 11, it's almost like it's overlapping, but once I get to 12, that's why I know it is matched up. So as soon as I get to 12, notice how it matches up with that number. So I'm multiplying this entire function by 3. Let me try that again. So let me say, so this was 4. So as I get closer, notice how as I increase that number, I'm getting closer to the blue line. And I'm saying, okay, it's like I'm multiplying this blue line by 3 to get this line. So I have to change this last constant to a 12, and that's when they overlap. So as long as I change that to a 12, that's when they overlap. Okay. Moving on. It says match each graph to its equation. So what I want you to do when you do this is look at y-intercept first. And what that means is you're looking at the y-axis. Where does it hit the y-axis? So for my first one, I'm going to say, well, I highlight my y-axis. Where does it hit? It hits at that point of 3. And I can say it has a positive slope. So this is then I say look at slope for positive, which goes up and to the right, or negative, which goes down and to the right. So we're going to say for this first one, number 1 is going to be a. So 1 goes with a, since this is 2x plus 3. You can notice how I'm increasing 2 steps up for every 1 step right. However, for the next one, let's look at that one. If I highlight my y-axis, so let's highlight our y-axis. I can say, well, hey, I noticed that it is at the point, it hits the y-axis at the point -3, and it also has a positive slope, so this should be 2x minus 3. So we're going to say it's going to be this one right here. So this one is going to be B. So that's number 3. For that choice C, just looking at a negative slope, and what's our y-intercept? Well, our y-intercept is the point +3, so I should have my equation as -2x plus 3, which is going to be number 2. So that's going to be this one right here. So this is going to be C. And that means, last but certainly not least, still the same setup. Highlight your y-axis, find your starting point, your point at where it hits the y-axis. So negative slope, -2x, and I have a negative y-intercept of -3. So that's going to be choice 4. So this one is going to be D, number 4. All right, so make sure you can use those 2 tools with using your y-intercept first, and then use your slope to be able to tell you which one you're looking for. And speaking of slope, it says here are 2 points. What is the slope of the line between them? So what I suggest you do, write your 2 points down. So I have -3, 4, and I have 1, 7. Let me write that a little bit better, 7. And let's find, again, as a reminder, we say slope, make sure it's still up, yep, slope, there it is. Slope is equal to the change in y divided by the change in x. What I mean by that is I'm saying my change in y is going to be +3, and my change in x is going to be +4. So I just write the ratio like this. I can say this can be equal to, I have 3 over 4 as my slope. Jeez. So just always write the ratio. If you need to simplify, you can, but we're going to say this one is going to be B. So make sure you just have that definition for yourself for slope, because we talked about that in Unit 3. Be sure to use Desmos to graph out your systems of equations. Make sure you can pause, rewind, ask questions as needed, and as always, super slam that subscribe button.